In this video, I want to solve these two problems. Let's start off with the first one. We have x to the 92nd power is congruent to 5 mod 31. Let's recall Fermat's little theorem says that a to the p minus 1 is congruent to 1 mod p, where p is a prime number. In this case, p is going to be 31, and p minus 1 becomes 30. A is going to be x. So we have x to the 30th is congruent to 1 mod 31. I want to know x to the 92nd power. So why don't we just get to x to the 90th first? In order to get to x to the 90th power, we have to cube both sides. Exponent to an exponent says x to the 90th power is congruent to 1 mod 31. Finally, I can get to x to the 92nd power by multiplying both sides by x squared. So I have x to the 92nd power is congruent to x squared mod 31. So what does this mean? This means that instead of looking at x to the 92nd power congruent to 5 mod 31, I could instead look at x squared congruent to 5 mod 31. That's what this means. So I was able to get something really large and simplified it to something small. Okay, so this is what I have. I'm left with x squared is congruent to 5 mod 31. And so this is going to make things a lot easier because now I can subtract both sides by 5 and get that x squared minus 5 is congruent to 0 mod 31. So x squared minus 5 has to be a multiple of 31. Now here I should have said that we're looking for values, positive values, less than 31. Okay. So technically k here has to be positive. So positive integer. So if I add both sides by 5, I get x squared is 31k plus 5. And so what I'm looking for is positive or perfect squares such that they are multiples of 31 plus 5. So let's look at our table here. We're looking at values between 1 and 30. And if 31k plus 5 is the x squared, and so the square root of that is just x. There's only two values that are less than 31 where they are perfect squares. That's for x equals 6 and x equals 25. So those are going to be our answers. The next problem, I have 32 raised to the 41st power mod 100. In order to solve this problem, we have to look at 32, 24, 68, and 76. These are the remainders when I raise it to an exponent mod 100. So the first spot we have 32 raised to the first power. That's congruent to 32 mod 100. Now 32 squared is congruent to 24 mod 100. And then 32 cubed is congruent to 68 mod 100. And then finally, 32 raised to the fourth power is congruent to 76 mod 100. So as we can see, if I was to do, let's say, 32 to the fifth power, that would put me up here. That would be 32 mod 100. And then sixth power would be congruent to 24 mod 100. Seventh power is congruent to 68 mod 100. So it's just going in a circle here. Notice in this spot right here, it's going to be multiples of 4. So it'll be like 4a 12, and then let's say all the way up to 40. I want to go to 41. So 41 is going to be up here. So 32 to the 41st power will be congruent to 32 mod 100. And so if we're looking for the last two digits of 32 raised to the 41st power, it's going to be 32. And that's our answer.